Alright everyone, welcome to part 5 of chapter 13, Achieving Energy Sustainability. And today's topic is solar energy. And so we'll first look at passive solar heating a little bit, then we'll look at active solar energy technologies, and then the benefits and the drawbacks of both of them. And our objective today is being able to explain the advantages and the disadvantages of solar energy. So the first thing I want to point your attention to is this picture here. This shows us our geographic variation in solar radiation in the United States. And so what that means is it's the amount of solar energy that's available to a flat photovoltaic solar panel in kilowatt hours per square meter per day, averaged over the course of a year. So what we can see is that in the southwestern United States, that's where we're going to be able to produce the most amount of electricity from solar power. So what that means is on average in the dark red, between 6.5 and 7 kilowatt hours of energy are able to be produced per square meter per day. Okay, here in Connecticut, we're looking at roughly between 4.5 and 5 hours over the course of a year. So between 4.5 and 5 kilowatt hours of electricity is able to be produced. First, we'll look at this is solar cookers. That's a great example of passive solar heating. Okay, and we saw in the previous section here in chapter 13 an example of passive solar heating in home use, in home heating. But I do just want to really quickly talk about solar cookers. If you remember back to freshman year, you all built a solar cooker, and solar cookers, if if you're using the right materials, and you've got the the right angle of the sun in certain geographic locations and latitudes, temperatures can reach roughly 350 degrees, and these can be used for a variety of different things. Boiling water, cooking traditional dishes of rice, beans, chicken. So again, they're very, very practical advantages. They can reduce deforestation, so really reduce the amount of wood that's needed to cook. And then also in terms of safety of refugees. This picture is from a refugee camp in Chad, and what that using the solar cooker reduces the need for these refugees to travel outside the camp. So that helps the refugees in terms of being able to provide food for themselves and not have to jeopardize their safety. Now switching to active solar energy technologies, we can actively capture the sun's energy, and we've got a couple of different systems here that we're going to talk about. But first, active solar energy in general, what that is capturing the energy of the sunlight with the use of either a pump or a photovoltaic cell and generating electricity. So first we'll look at a solar heating pump, and I've got a picture on the next slide to show you of that. Then we'll talk about photovoltaic systems, and again I've got a picture of that. And then lastly we'll talk about concentrating solar thermal electricity generation. So first thing here, first bullet is the solar heating system, and that is pretty much what it says there. Great examples are pools, cooking, cleaning. What happens is on this slide here, we can use a solar collector to heat a liquid, and this liquid is it won't freeze, but what that liquid does is that liquid absorbs the solar energy, okay, from the sun. And then that liquid circulates through the system. It brings, you can see the arrows here. So the liquid warms, which is represented by the red color, and then that liquid warms and is brought down into the circulation pump and the heat exchanger. And it's at the exchanger that heat is passed on to water. And that water can be used for all the reasons that we just mentioned: cooking, cleaning, pools. Again, it's how we can make hot water. So solar domestic hot water system, we can use the energy from the sun. That energy can be used to warm this circulating liquid. That liquid is brought down to the heat exchanger, where the heat is transferred to the hot water, or to the water, which makes it hot, and that hot water can be used. And then what happens is this circulating liquid obviously then cools down, and then that liquid is pumped back up to the roof, back up to the collector, where it is warmed again. So again, that's solar domestic hot water system, which is right here. A photovoltaic system, this is going to capture the energy from the sunlight and convert it directly to electricity. So photovoltaic systems, very similar, it's basically the same thing as a solar panel. And so solar panels capture the energy from the sun, convert it to electricity. And here's our picture. So we've got our photovoltaic panel up here, and again it absorbs the sun's energy. And these photovoltaic solar panels, they're very thin and they're ultra clean layers of materials, and they are able to generate a low voltage electric current when they're exposed to the direct sunlight. So it excites the electrons, and once those electrons are moving, we can convert them low voltage we can convert that to a higher voltage, and we can send that out onto the grid. Okay, so again, the electrons are sent through the system. We can convert the electricity, bump it up to a higher voltage, and then send it out on the way. Now, some systems are depending on the system. Some systems are also hooked up to a battery. So the solar panels can be used to generate electricity, which then will charge a battery, and the battery will be able to store the electricity for use when the solar panel can't work, on a very cloudy day or stormy day or nighttime. Other systems do not have the battery, and they're just able to generate the electricity for use when it's sunny outside. And one of the other really great advantages of solar energy is that if there's more electricity left over, so if you've got this house here and this house is using uses some of their electricity, but they've got even more left over, that electricity can be sold back to the power company, or could be credited for future use. So that's a really great plus with the photovoltaic solar panels. The last thing I want to mention is the concentrating solar thermal energy, concentrating solar thermal electricity generation. These are going to use lenses and mirrors to focus the sunlight to make steam turn the turbine in a traditional, in more of a traditional sense. So if you look at this picture here, all of these mirrors focus the sunlight, and they're able to be adjusted throughout the course of the day, so that all of the mirrors here focus their sunlight on a one central location. So we've got concentrated the solar energy being focused up here, and all that heat from the concentrated solar energy is going to be used to heat water, evaporate water, turn it to steam, and that steam will turn a turbine. And the turbine connected to the generator makes the electricity. So this is again related back to electricity generation. Now, obviously, here we need a lot of space, a lot of land to do this, and obviously they're not going to be able to generate the electricity at night. So just briefly talking about benefits and drawbacks, to summarize what we've talked about here. Our benefits of our solar energy systems: we don't have any air pollution, there's no water pollution, there's no CO2 emissions, and other than the area that we need, if you've got one of the CSTs, there's really no ecosystem disruption either. So there's no pollution, no air, no water, no CO2 emissions, really minimal environmental impacts. And the other benefit here is that electricity is produced when the energy demand is great. So again, as we talked about, there's a peak demand of electricity, in the afternoon when the sun's up. When it's very hot outside, people want the air conditioning, and that's when these systems are able to be used to their full extent. And then after the initial installation cost is repaid, electricity generation is pretty much free, as long as we've got the sun, which we'll have it for a very long time. The drawbacks, though, of solar energy systems is that these systems can be very expensive to install. The cost of photovoltaic solar panels can be daunting. for certain individuals to install. However, there are subsidies and tax credits that governments can offer as incentives to really push the agenda. Germany has actually made solar energy a part of their sustainable energy agenda to subsidize the initial cost of the solar panels. And there are different, in the US, there are different tax breaks that are available. But those, again, they could be increased. And then in terms of environmental drawbacks, these solar panels themselves, they do require a lot of energy and a lot of water to make. And they can also, again, depending on the technology, they can also involve the use of toxic metals and chemicals. But as the technology gets better and increases, we're hoping to be able to minimize these toxic chemical and toxic metal use and really reduce them. And solar energy can be a very, very promising source of energy into the future. So checkpoint questions, we've got the 3 here. Again, please try and answer these in Edmodo if you can. In what ways do humans capture solar energy for their use? Why are active solar energy systems not feasible everywhere? And lastly, how does active and passive solar systems work, or how do they work, sorry, and what are the advantages of each? So please go ahead and answer these either in Edmodo or on a separate piece of paper and be ready to hand them in on the due date. And then once you're finished up here, you can move on to the next section, which is all about geothermal energy.